Hi everyone! In this series of videos we're going to walk through a slightly different twist on the geometric series that you were exploring in the previous lesson, and we're going to look at what happens when you add up what we call an infinite geometric series. If that seems counterintuitive, I hope that you're thinking about that already, because if you just heard me say that phrase, infinite geometric series, then hopefully you latched on to two key words there. Infinite and series. A series is when you add up a bunch of things. So a series is what you were doing, for example, in question number 4. 2 plus 4 plus 8 plus 6 plus 32, and goes on and on and on and on. Now, the word infinite means it goes on forever. And that's not what you were doing in question number 4. In question number 4, you were adding up a lot of numbers, but you were stopping at the 30th term. There was a definitive stopping point. And intuitively, you probably realized we had to have a definitive stopping point. You can't keep adding these numbers forever, because 2 plus 4 is 6, that's getting bigger. 6 plus 8 is 14, then plus 16 is 30, then plus 32 is 62, and then as you keep going, it's just getting bigger and bigger and bigger. If the numbers are going on forever, you're just going to keep getting a bigger and bigger and bigger answer. The answer to this sum would be infinity. It's like not even possible to land on a distinctive answer, because there's no way that you could ever stop adding. You're going to always keep getting bigger and bigger and bigger. So it probably seems counterintuitive that we're even going to bother doing questions with an infinite series, because you're probably sitting there going, well, I'm going to stop this video right now. If all the answers to question number 6 are just going to be infinity, 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 then I'm just going to stop. Because I already know this, that's intuitive to me, and that's obvious. But it's not actually true that all of the answers in question number 6 are infinity. Most of these, in fact, all of these, have an actual numerical answer. And if you're thinking, how is that possible? How could you add up an infinite number of things and get an actual numerical answer? That doesn't make any sense. There's a little bit of a loophole in this question that allows it to make sense. And to see that loophole, to understand that loophole, I'm going to ask you to look at a visual experiment that I'm going to try to replicate to walk you through to question number 5. This is an experiment that I would have you do in person if you wanted to do it. So if you have access to a piece of paper that you're willing to cut up, and either scissors or the ability to simply tear that piece of paper, I'm going to ask you to pause this video and grab a piece of paper so that you can duplicate this experiment for yourself. What we're going to try to do is figure out how to visualize adding an infinite series of things, adding an infinite series of numbers. Now, for reference, and I just want to show you, I'm using a Post-it as my piece of paper, but I just want to show you the stack of Post-its from which I pulled this from. The stack of Post-its is obviously just a little square set of Post-its. So picture, if you will, that this is one Post-it that I'm going to start cutting up. The first cut that I'm going to make is half of the Post-it in size. So notice, I'm going to take half of the Post-it. And I'm going to even label it. I'm going to call this 1/2, just so we know that that is half of the original Post-it. And if I compare it back to the original deck of Post-its, I can clearly tell, yep, that's like half as big as it started out. So you can tell it's half. Now, I'm going to take the remaining half, the other half of the Post-it, and I'm going to cut it into fourths. Now, or I should phrase it this way. I'm going to cut it in half. So I'm taking the half of my remaining Post-it and cutting it in half. Now the reason I said the word 1/4 is because half of a half is a fourth. So in theory, if I compare this to the original deck of Post-its, and I'll probably want to compare it to a different one so I can see the color contrast here. Comparatively, that is about 1/4 of the original Post-it. So you can tell that this fraction is 1/4 of the original Post-it. Then I'm going to take the remaining little sliver that I still have, and I'm going to cut it in half. And I'm going to think of that little sliver. I just took half of a fourth, which means theoretically this little sliver of Post-it must represent 1/8 of the original. And again, I can visually compare. Comparatively speaking, it does look like it would take 1, 2, 3, 4, 5, 6, 7, 8 of those little slivers to compare to the size of original Post-it. So, yep, 1/8 seems reasonable. Then it's going to start getting a little bit tricky. I'm going to try to take half of an 1/8. And this is where I regret my choice of scissors, because obviously I need a very tiny little surgical implement to be able to make these cuts. And as I cut, now I've got this teeny little sliver, half of an 1/8. This teeny little sliver must be 1/16 of a Post-it. And then I'm going to keep repeating this process. Now obviously this process is going to get very difficult, and I may now just be broadcasting to the world what will eventually be a horrific scissors injury. But hopefully you can see where this is going here. That by the time I keep cutting, and I'm off camera trying to cut without making myself bleed, so please don't judge my terrible cutting quality. But by the time you start to get down to these really little slivers, remember the question I posed at the beginning of this video? What would happen if you add up an infinite series of things? Think about what's happening now as I'm adding up this little sliver situation. I'm up to 1/32, which is getting pretty tiny. So tiny it's hard to even write. But then I'm going to have to start thinking about half of that. And I'm at the point now where I can't even think about half of this as a skinny little strip, so I'm going to cheat a little bit. I'm going to cut half the other way, because that doesn't involve losing a finger. So half of 1/32 must be 1/64. That's this little sliver. And then if I take another half of that, so again I'm cheating, taking half the other way, there's another half, and that's half of 1/64, so that's 1/128. And then I'll take half of that, which is 1/324. And then I'll take half of that. Ooh, jeez. Or sorry, 1/256. I misspoke. You can tell these are getting almost trivial because I'm down to such teeny tiny little pieces. It's probably hard to tell. And these are all of my little pieces, including these little itty bitty slivers, which are becoming increasingly difficult. And I'm down to this, which I can keep cutting in half if you really want me to. I mean, if at this point it's just Struggletown Population Herbert and you're thinking, oh gosh, I think I know where this is going, this might be a good time to kind of reinvest our thinking a bit. Remember, comparatively, these are half of a Post-it, 1/4 of a Post-it, 1/8 of a Post-it, 1/16 of a Post-it, and so on and so forth. Let's compare again to my original Post-it. The blue is the same original size, so this is just for comparison's sake. There's half, and there's a 1/4, and then here's my 1/8. I'm just sticking these all together so I can see them a bit more clearly. Here's my 1/16. And then it was starting to get a little bit difficult, but here's my very impossibly skinny 1/32. And then I started having a bit more trouble, so I started cheating. Half of that 1/60, or 1/32 was 1/64. And then the next half of that was my 1/128, which gets hard to pick up. You seeing where this is going, though? If I start to try, apparently desperately, to stack all of these little things back on their original Post-it and ask myself, what do they all add up to? Does it really seem to matter that I can keep cutting forever? I mean, I'm getting down to such tiny pieces. Look at what I have left to cut. I have left, at this point, so tiny that I'm having trouble even picking it up off of the surface, this tiny little sliver there. And what's left for me to cut, which is getting too impossibly tiny, is this teeny tiny little sliver that you probably can't even see unless you're zooming in on the video to an excruciating level. And then you'd ask yourself, if I keep cutting those tiny little bits, is it even going to matter? At some point, aren't I cutting such tiny, infinitesimally small little bits that, yeah, I could do it forever, but at that point, I'm like splitting atoms? Because at that point, maybe you're not adding a very significant quantity anymore. think about the significant parts of this addition, the parts that I really want to make sure that I see. I was adding 1/2. I can clearly see that part. I was adding 1/4. I could clearly see that part. Those were nice big post-its. I could add 1/8. I could clearly see that. Then it started getting a little skinny. 1/16 was a little tough, but I was there. 1/32 is where I started to reach the limits of my dexterity. 1/64 was where I started to reach the limits of my sanity. And then beyond that, I started really just kind of cheating. And 1/128th, and the next one 1 over, let's see, what is that, 256, and then the next one 1 over 512. I mean, I started losing patience to the point where I think I stopped counting, and I believe it was 1 over 1024 where I stopped cutting altogether because I was afraid of having an injury. So at this point I'm going to use a little ... to show I could do that forever. If I wasn't limited by my own clumsiness and bad scissors, I guess I could have done this a little while longer, but again it poses the question, do you need to bother? Because at some point, aren't you adding up such a tiny, tiny, tiny little number that it's almost like adding nothing at all? I mean, if I lied to you and said that I had a little atom splitter over here at home and that I was splitting atoms and adding them to this picture, they were so tiny that your screen couldn't possibly capture it. You don't have a high def enough screen to possibly see the teeny tiny little bits of post-it that I'm adding. I mean, you would think, she's lying. Because you can't see them. They're so small at that point. You're not really adding meaningful chunks of post-its anymore. Therefore, we can conclude that at some point, you're really not adding anything of value. And it is possible to say, hey, you know what? Yeah, even though I'm adding up an infinite series of numbers, eventually it's like I'm kind of petering out. I'm getting to the point where the answer is kind of stable, and anything extra that I add to my answer isn't going to discernibly change my answer. So let's picture it. 1/2 of a post-it, plus 1/4 of a post-it, plus 1/8 of a post-it, plus 1/16 of a post-it, plus 1/32 of a post-it, plus 1/64 of a post-it, plus more and more little bits of post-it. Even the tiny little infinitesimally small bits seem to add up to, if you look at it carefully without me moving it so much, sorry about that, seems to add up to one full post-it in size. And that if I really did a good job of precisely lining these up, which I have to admit I did not, you can tell that all of those little slivers are going to add up to one full block of the post-it, just like I started with. So what that actually means is that if we take 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32 plus 1/64 and went on and on and on and on and forever, even if it goes on to the point where you're cutting impossibly small little things, that the overall sum of these pieces is one whole, or one full piece of paper. So as counterintuitive as it might seem, adding an infinite series of very, very, very small things is possible. And it adds up to one of the actual thing that I started with. Now, again, the mind-blowing part here shouldn't be that it added up to one full post-it. It should just be, it's possible. It's possible to actually get yourself to the point where you can kind of visualize how much of a post-it you have and say, oh, cool. I can actually add up all those little things because all the small bits get so small that I don't have to bother with them anymore, and I can visualize what's going on without making a ridiculous task for myself. So it's almost like once you get into the ... part of the problem, those things are so small you don't even have to focus on them, and you can focus on what 1/2 plus 1/4 plus 1/8 plus 1/16 is, and you can use that as your better estimation. These bits are all going to get so small, they're not really going to change the biggest parts. The biggest parts are what's doing the lion's share at the adding. The 1/2 plus the 1/4 plus the 1/8 plus the 1/16, that's where I can see the full size of my post-it starting to emerge. All these little things, not very helpful at all. So, in the time between now and the time you start the next video, take a look at letter C and make a prediction. What if we weren't using halves? What if we were ripping our post-its into thirds? What would be the sum of the thirds? We know it's possible to add up a whole bunch of tiny little thirds. What do you think that would add up to? How much of a post-it? And in letter D, what if we did fourths? How much of a post-it? So then that kind of begs the question, now that we know it's possible to add an infinite number of things, is the answer always going to add up to one full post-it? Is it going to be different depending on what size we're tearing it into? Play with that a little bit. And in the next video, I'll do the thirds and the fourths so that you can see how it actually emerges. But this is kind of an experiment, a little food for thought before I have you get into the real problems in question number 6. So bear with me as we kind of play around a little bit, and then I'll give you the information that you need to actually get to the formulas where you can solve the problems.